few days ago, I came across this video of a bird pretending to be dead in someone's hand before suddenly flying away like nothing happened. And it got me thinking, why is it doing this? Is this just a deer in the headlights kind of fear response or something more? And is this actually effective? Well, after looking into it a little bit, it turns out this isn't random at all. It's a real scientific phenomenon called Thanatosis, named after the Greek god of death, Thanos. Thanatos, and it's one of the strangest forms of animal behavior ever recorded. Thanatosis, also known as tonic immobility, or your muscles locking up, refers to when animals fake their own death in an attempt to survive. And what's really weird is that there are hundreds of animals that do this, from crustaceans to birds, beetles, sharks, frogs, snakes, butterflies, rabbits, stick insects. There's hundreds of examples across the animal kingdom. It's really quite a bizarre example of convergent evolution, and for a while it had scientists scratching their head about how or why this even came about. So next, let's take a look at a couple of these examples. What you're seeing on screen is a species of snake typically found in the region of southern Canada, the United States, and northern Mexico called the hognose snake. When threatened, it flips onto its back, opens its mouth, and emits a foul-smelling ooze from its body in an attempt to make it both look and smell like it's decaying. And the result is that predators instinctively back off and avoid eating it as a precaution against infectious disease. But here's the thing. When we say these animals are playing dead, they're really playing dead. It's not the same as when animals freeze to avoid being noticed, because freezing usually happens when they notice the predator and before a predator detects them, and is typically done in an attempt to better camouflage themselves, while tonic immobility occurs after the predator has already made contact and there is no chance of escape, and is done as a last-ditch effort to prevent further attack or being eaten. From a physiological perspective, they also result in different things. During freezing, heart rate and breathing ramp up as the body prepares for action in case the predator starts chasing them and they need to escape. While during tonic immobility, it's the opposite. Everything slows down, from heart rate to breathing to general metabolism. And the best and most famous example of this is the Virginia opossum, which is also frequently found in the regions of Canada and the United States. And it's where the term playing possum comes from. So when threatened, an opossum doesn't just freeze or collapse, it enters a full-blown physiological shutdown. Its heart rate slows by nearly half, its breathing slows dramatically, and its body goes completely limp, with its eyes typically glazed and tongue hanging out. It even releases a foul-smelling fluid from its anal glands that try to mimic the odor of decay. And the result is surprisingly effective. Predators have often been observed stopping their attack midway and walking away in search of better, healthier prey. What's crazy is that this isn't a conscious choice. The opossum's brain triggers this automatically. It's a hardwired reflex, and the opossum can remain in this state for up to an hour before wandering off as if nothing happened. So after all this, how on earth did animals even develop these traits? The specific way an animal plays dead varies based on the species and the environment that it's in. For example, playing dead may be effective against predators that prefer live prey, but may become completely useless against scavengers like hyenas, or in ecosystems where the scarcity of food means that predators can't afford to be picky. But the way animals perform this act is just as interesting as why they do it. For example, while I was doing my research, I came across a study done on the pygmy grasshopper in 2006, which revealed that when it was under attack by a frog, the grasshopper adopted a pose that basically increased its functional body size and exposed its spines. And what this did was that it made the grasshopper pretty much impossible to swallow for smaller frogs that normally could swallow it when it was in its usual posture. And even for slightly larger frogs, it was only able to swallow the grasshopper after a lot of attempts to position it correctly, which made it a much less attractive option compared to other prey. And what's really interesting about this is that when these frogs grew up, meaning they could now easily swallow the grasshoppers no matter what they did, when they were released into the wild, they preferred other prey that were available in the area. And when the scientists looked further, they noticed something else that was really interesting, which is that the grasshoppers never showed this behavior in response to birds or spiders or other predators that don't need to consume their prey whole. And what this showed was that the pygmy grasshopper specifically and intentionally developed this adaptation against one of its main predators, rather than something that just stumbled into its genetic code. One of the most unique instances of tonic immobility can be found in two species of predatory cichlid fish, which are native to areas of Africa and Central America, and they actually pretend to be dead as part of their hunting strategy. So what they do is they adopt a pose that makes it look like they're dead, and they let themselves slowly fall down to the bottom of the riverbed. And what this does is it attracts other fish that try to scavenge from it, only to realize it was a trap when they swim close by or near its mouth. It's one of the few instances in nature where tonic immobility is actually used as a hunting strategy, and it goes beyond simple camouflage. The spots on the fish actively make it look like a decaying corpse, and you can see in this video when it closes its eyes, it almost looks like they've been hollowed out. But when I was looking into this, I couldn't help but wonder, how did they even develop this hunting style? And after searching through pages and pages of articles and videos, and there's not a lot of information on this, the most likely explanation I could find was that these species of cichlid fish live in complex freshwater ecosystems such as Lake Malawi and Lake Victoria, where there's intense competition for food. They feed on smaller fish that are naturally cautious and wary, and some of these fish will only approach targets that seem dead or easy to catch. Also, importantly, you can actually see underwater, where in murky riverbeds this tactic simply wouldn't work because they probably just end up at the bottom where no one can see them. But prey species also evolve simultaneously with their predators, so curious prey might learn to inspect motionless animals cautiously. So it's likely that at one point these two particular species of cichlid fish just had variations in how they looked, but over time end up refining how they play dead, both in their behavior and appearance to gain a survival advantage in an evolutionary arms race. Some particularly intelligent animals like orcas actually abuse tonic immobility against its prey. For example, they may flip young great white sharks over and over to induce tonic immobility for prolonged periods of time, causing them to suffocate as they need to move in order to breathe. And you've probably also seen some viral clips of this happening online too, where people have been flipping sharks over or turning them on their heads and they go completely still. It's quite bizarre, but it almost looks fake, but don't worry, the sharks in these videos are fine. Usually after about 10 to 15 minutes, they snap out of paralysis and they're fine to swim off again. It's only when you do it over and over that it causes significant problems. Thanatosis shows just how creative evolution can be. And it really makes you wonder how, out of all the possible skills an animal could have, like speed or strength or camouflage, how on earth did so many animals decide that being better at being dead is somehow the best option? But where I live, I've never actually seen an animal do this in real life. If you have, please let me know in the comments. Was it effective? Did they end up getting away? I'm genuinely curious. And thanks for watching. If you enjoyed this video, leave a like, comment, and subscribe, and I'll see you in the next one.